My dear friends, so far I told some problems about complex numbers. There is a lot of syllabus in the complex numbers. Later let us discuss. Now I am going to deal limits and continuity. Limits and continuity, new chapter. Okay? Limits and continuity. Aggregate. What is meant by aggregate? Definition. Any non-empty subset of real numbers is called an aggregate. We have N, W, these are all subsets of R. These are all subsets of R. These are aggregates of R. Not only these, if A comma B belongs to R and A less than B, to R and A less than B, the open interval AB X such that A less than X less than A is an aggregate. Similarly, left closed, right open, X such that A less than or equal to X less than A. These are all aggregates. Similarly, left open, right closed, X such that A less than X less than A. X less than A. This is closed interval. X such that A less than X less than or equal to A. All these are all aggregates. Origin. This is minus infinity. This is plus infinity. Here this is R minus. This is R plus. This is R plus. Now this is denoted by minus infinity to 0. Union. Singleton 0. This is 0 to infinity. This is 0 to infinity. These are also aggregates. Aggregate means any non-empty subset of real number R is called an aggregate. In the definition of a limit, we should have some proper knowledge of neighborhood of a point. Neighborhood X belongs to R. For given epsilon greater than 0, the open interval x minus epsilon x plus epsilon is called a neighborhood of a point X. It is denoted by n epsilon x. N epsilon 0. Epsilon is always lies 0 to 1. This is x minus epsilon. This is x plus epsilon. This interval is called neighborhood of a point. There is a some conclusion. N epsilon x minus x. This is called deleted neighborhood of x. Deleting the set x. Next, n epsilon x minus x minus 2x is called left neighborhood of x. Left NBD of x. Similarly, n epsilon x plus is equal to x plus epsilon. This one, right NBD of x. Example is equal to 2. Epsilon is equal to 0.5. N epsilon x is equal to 2 minus 0.5. 2 plus 0.5. This is 1.5. 2.5. For example, this is 2. This is 1.5. This is 2.5. This is 2.5. Is called epsilon neighborhood of 2. Neighborhood of a point. Depends upon the value of epsilon. For example, is equal to 2. Epsilon is equal to 0.1. Then n epsilon x is equal to 2.2 minus 2 plus 0.1. This is 1.9. This is 2.1. This is also neighborhood of 2. This is also neighborhood of 2. These two sets are very different. These two sets are very different. This is subset of this one. Second one is subset of first one. Second one is subset of first one. So that puts that must be a modulus of x. This is one of the definition frequently comes in the limits. Some problems in calculus. X belongs to R. Modulus of x is denoted by mod of x and is defined by modulus of x is equal to minus x if x less than 0, if is equal to x if x greater than 0. This is the modulus of x. Friends, you should always greater than or equal to 0. Mod of x is always greater than or equal to 0 because x is equal to minus x when x less than 0, but minus x is greater than 0 because when x less than 0. We have already mod of x is equal to x. Therefore, mod of x is always greater than or equal to 0. This is positive. Minus 4 is equal to 4. How to explain this? This is x is equal to minus 4 is less than 0. So modulus of minus 4 is equal to minus of minus 4. This is 4. Minus of minus 4. This y belongs to R. Modulus of xy is equal to mod x into mod y. Mod x into mod y. Similarly, friends, mod x by y is equal to mod x by mod y. Mod of x whole square is equal to x square. Mod of x whole square is equal to x square. These are all primary properties. These are all primary properties. X minus a is less than epsilon. Modulus of x minus a is less than epsilon. This implies a minus epsilon is less than x less than a plus epsilon. A plus epsilon. Minus a less than epsilon means x belongs to in the neighborhood of a. X belongs to in the neighborhood of a. Modulus of x minus a less than epsilon means x belongs to in the neighborhood of a. Okay, define a limit. We must have very clear idea on limit point. Limit point. You see, let x be a real number. Let x be a real number. For given epsilon greater than 0, there exists a epsilon for given epsilon greater than 0. Epsilon greater than 0 such that n epsilon x intersection s is equal to infinity. Then we say that x is limit point of s. The set of all limit points of s is denoted by d of s. D of s. Friends, before we going to discuss the definition of a limit, domain of a function must have limit points. Must have limit points. Otherwise, we cannot define limit of a function. We cannot define limit of a function. Define a function to define a limit of a function. The domain of a function must have limit points. If it has no limit points, we cannot discuss the limit of a function. Before going to learn this limit of a function, there exists a n epsilon x intersection s must be infinite. Then we say that x infinite set. Then we say that x is limit point of x. This is the set is an aggregate of R equal to 2, epsilon is equal to 0.5, epsilon is equal to 0.5, n epsilon x is equal to 1.5 to 2.5. Now n epsilon x intersection n is not equal to is 5 minus 2 is this is 5. This is 5. That means this is not a infinite set. This is not a infinite set. Therefore, not infinite set is not infinite set. Therefore, 2 is not limit point of n. Not limit point of n. So that any point of n is not a limit point. Any point of n is not a limit point of n is equal to 5. Similarly, whole numbers is 5, z is 5, z is 2, z are not useful to define a function at limit domain of a function. Domain of a useful as the domains of a functions to discuss the limit of a point. To discuss the limit of a point. Limit points. These have no limit point. L to R. Limit of f of x. This is wrong concept.